Building reliable AI system requires more than just powerful language models. Let me just start with a small question. Have you ever noticed how AI tools sometimes sounds very confident but still gives you the wrong answer? They speak fluently, they sound intelligent, yet the information can be outdated, incomplete, or completely made up. Now imagine building an AI system that doesn't just talk well, but actually looks up the right information first and then gives you the trustworthy, evidence-based answers. That's exactly what today's course is all about. Welcome to this course on Retrieval-Augmented Generation or RAG using Python. RAG is one of the most important techniques behind modern production-ready AI systems. Instead of forcing a language model to answer purely from its memory, RAG teaches the model to behave more like a human expert. First is retrieve relevant information, then use that information to generate an answer. This simple idea solves some of the biggest problems in AI today, like hallucinations, outdated knowledge, and lack of context. And the best part, you don't need to retain massive models. You simply connect them to your data. In this course, we are not just discussing RAG as a theory, we will be building it step by step using Python. You'll see how real-world systems such as search documents, compare meaning using embeddings, retrieve only what matters, and generate accurate, grounded responses. We'll move from concepts, architecture, working code with live demos. By the end of this course, you'll have a clear understanding of what RAG is, why it's essential for modern AI, how retrievers, generators, and vector databases work together, how to build a RAG based on question answering systems, and a RAG based summarization systems, and even a dialogue based RAG chatbots. You'll also be using tools like FAISS's T5 fit into real pipelines, and most importantly, how to design reliable AI system, not just demos. This is the same architecture used in customer support bots, search engine, medical systems, and enterprise AI tools. Before we begin, let me ask you a quick question. What is the main goal of RAG? Is it better language fluency, faster model training, retrieve before generate, or is it replace databases? Let me know your answers in the comment section below. Before we begin the course, if you want to move beyond just using AI in action, in the description box below and in the pinned comments. Before we go into the technical details, let me first explain the idea behind RAG. RAG stands for Retrieval-Augmented Generation. In simple words, it means the model does not answer immediately. Firstly, it retrieves relevant information and then it generates an answer. Normally, language models respond only based on what they learned during the training. That knowledge is fixed and cannot update itself. This becomes a problem when information changes or when the model has never seen that data before. RAG solves the problem of allowing the model to search external sources like documents, databases, or knowledge bases before answering. So instead of guessing the model answer using real and relevant data. If you look at the diagram, you can see the flow clearly. The user takes a question, the retriever searches the data sources, relevant text is fetched, and finally the LLM generates the response. So the key takeaway from this slide is that RAG makes AI response more reliable, accurate, and grounded in real information. Now that we have understood what RAG is, let's talk about why is it important. The first reason is accuracy. Since the model retrieves real information before generating an answer, the response becomes much more reliable without RAG. Models may sound confident but still provide incorrect information. The second important reason is hallucinations. Hallucination means the model generates information that looks correct but is actually false. This can be dangerous in real-world systems like healthcare, finance, or even legal applications. RAG reduces hallucinations because the model uses retrieved evidences instead of imagination. Third reason is contextual understanding. RAG helps the model understand what information is relevant for the current question, so the answer is more context-aware instead of generic. Next is scalable knowledge. In traditional models, adding new information often requires retraining the model, which is expensive and time-consuming. With RAG, we don't need to retain the model when data changes. We simply update the external data sources and the model can immediately use the new information. Next point is efficiency. RAG retrieves only the most relevant data for a query instead of processing everything. This makes the system faster, more precise, and cost effective. Now let's move from the theory to real world application. One of the most common use cases of RAG is customer support. RAG based chatbots retrieve answers from FAQs or manuals instead of giving generic responses. In search engines, RAG combines retrieved information with generation to provide more meaningful results. In medical system, it retrieves patient data or research papers before generating insights for doctors. In legal research, RAG retrieves past cases, generates summaries. So whenever accuracy and up-to-date information matter, RAG plays a major role. Next, we will be answering a very practical question. Where does RAG actually add the value in real world? The table shows different use cases, but the key idea is not the row themselves, it's the pattern behind them. If you look across all these use cases, one common challenge appears again and again. There is a lot of information and users want precise, trustworthy answers and not raw data. Let's see about customer support. In customer support systems, information is usually stored in FAQs, manuals, and internal documents. A traditional chatbot might give generic replies, but the RAG-based system retrieves the exact section of the FAQ or manual and then generate a clear user-friendly response. This reduces wrong answers and improves customer trust. Now consider search engine. Search engines already retrieve information, but the challenge is relevance, and understanding RAG improves this by retrieving the most relevant content and then generating a meaningful explanation, instead of just showing a list of links. This helps users get answers faster with better clarity. Next is medical diagnosis, where accuracy is extremely important. Here, RAG assists doctors by retrieving relevant medical data, patient history, or even clinical guidance. The generated response is then based on retrieved data, which reduces the risk of incorrect or unsupported suggestions. In content creation, the problem is usually context and coherence. RAG retrieve relevant articles or reference materials and then helps generate content that is consistent, accurate, and well structured. This is especially useful for research-based writing. Now let's take a look at legal research. Legal professionals deal with massive amounts of case laws and precedents. RAG retrieves relevant legal documents and then generates the summaries or insights, saving time and reducing manual effort. For virtual assistant, RAG helps by fetching real-time or updated information. Instead of answering from outdated knowledge, the assistant retrieves current data and generates context-aware responses. In e-commerce recommendations, personalization is the main goal. RAG retrieves product details, user preferences, and past behavior, and then generates recommendations that feel personalized rather than generic. Finally, language translation benefits from RAG by retrieving language-specific context. This helps generate translations that are not just grammatically correct, but also contextually accurate. So this table shows that RAG is not limited to one industry. It is a flexible approach that connects large data sources with intelligent, human-like response across many domains. Till now, we have understood what RAG is and where it is useful. Now it's time to understand how RAG actually works internally. At a high level, RAG has two very important parts, the retriever and the generator. Think of RAG like a smart student. Before answering a question, the student first looks up references material and then writes the final answer in their own words. In this example, the retriever is like searching the textbook and the generator is like writing the answer in the exam. Understanding this separation is very important, especially when we start building RAG systems using Python. Now let's start with retrieval part, because retrieval is the foundation of RAG. Retrieval in RAG, which stands for retrieval and generation, is a process of fetching relevant information from a large database before generating a response. The key idea here is before the model answer, it first looks up for relevant data. This helps the AI improve accuracy by grounding its response in authoritative information instead of assumption. Now let's look at the first step, which is retrieval. In this step, the model retrieves relevant documents or text passages based on the user's query. So when a user asks a question, the system searches through the stored data and selects only the information that is related to that question. Once the relevant information is retrieved, we move on to the second step, which is generation. Here, the model uses the retrieved information to generate a response that is more accurate and contextual relevant. So the answer is not created randomly, it is based on the information that was fetched in the previous step. So if I summarize the slide in one sentence, RAG first retrieves the right information and then generates the answer using that information. Now let's move on to augmentation. Augmentation in RAG, which stands for Retrieval-Augmented Generation, means using external data to ensure the model's ability to answer questions. So instead of relying on only what the model already knows, we support it with additional information. The first point here is the external data. Augmentations allows the model to retrieve relevant information from external sources such as databases, websites, or documents. This means the model is no longer limited to its internal knowledge. Second point is improved responses. Because the model has access to external data, it can generate answers that are more accurate and more relevant to the question. So in simple terms, augmentation is a step where we enrich the model with external information so it can answer better. Now that we have understood retrieval and augmentation separately, let's look at how everything fits together in the complete system, which is the architecture part. Now let's slow down and really understand this architecture because this diagram is the heart of how RAG works. I'll be explaining it step by step, but also explain why each step exists, not just what it does. Everything starts with the user. The user asks a question which we call a query. This query is usually written in normal human language like a sentence or a question. At this point, the system has no idea what documents to look at. It only knows the text. That query is then passed to something called as query encoder. The role of a query encoder is to convert the user's question into the form that the system can compare with stored knowledge. In simple terms, it helps the system understand the meaning of a question, not just the words. Once the query is encoded, the system moves to a vector store. You can think of vector store as a very smart storage system that contains all the documents, articles, or knowledge that an AI can use. Each piece of information in that store is saved in a way that makes searching by meaning possible. Now comes a very important step, which is vector search. Instead of searching by keywords, the system compares the meaning of the user's question with the meaning of the stored documents. This allows the system to find information that is relevant even if the exact words do not match. The result of this search is what we see here, which is the retrieved documents. These are the most relevant piece of information that the system believes can help answer the user's question. The entire process from encoding the query to retrieving documents is called the retriever part of the RAG. Now here's where RAG becomes very powerful. The system does not directly answer using these documents. Instead, it combines two things: the original query, the retrieved documents which act like a supporting context. This combined input is then sent to the language model or LLM. The LLM job is not just to search, its job is to read, understand, and explain. It looks like a question and retrieved information together and generated a response that sounds natural and humanly. This step is called the generator part of RAG. Because the generator is using the real retrieved information, the response is more accurate, more relevant, less likely to contain false information. The final output of the entire flow is a guaranteed response. This response is not just based on a model's memory, it is grounded in the external knowledge that was retrieved earlier. So if I explain this architecture in one simple idea, RAG works like a person who first looks up the right information and then explains it clearly in their own words. That is why this architecture is so important. It combines searching, understanding, and language generation into one intelligent system. This architecture shows how RAG makes AI systems more trustworthy by separating finding information from explaining information. Till now, I've explained what RAG is and how it works internally. Now, I want to show you how these ideas turn into real-world system. These are not just concepts, these are things we can actually build and run. These are the three main examples represented in most common and practical applications of RAG. The first one is question and answering systems. This is the most straightforward use cases of RAG. Here the user asks the question and instead of answering from memory, the system retrieves relevant documents and then generates an answer based on them. This is especially useful for things like documentation, search, FAQs, or internal company knowledge. Next, we have Summarization System. Instead of answering a question, the system retrieves long documents or text and generates a concise summary. This is useful when dealing with large files, reports, or research documents. The third system is Dialogue System. This is like a chatbot that can hold a conversation while continuously retrieving relevant information to stay accurate and context aware. Now I'll be explaining how to implement these systems practically. Before I start running the code, I want to explain what this program is doing at a high level. This will be a Retrieval-Augmented Generation question answering system. The idea is very simple. We need to store the document, convert them into embeddings, retrieve the most relevant documents for a question, generate an answer using a language model. This directly follows the RAG architecture that we have discussed earlier. Now, before we start, we need a project folders. So as usual, you can create a project folder via command prompt. Again, we can execute Python in two different ways, which is the command prompt itself, and we'll be moving on to Jupyter Python later. I'll show you both the ways. You can choose whichever is easier for you to work with. So firstly, we need to navigate to the location where the folder should be created. So CD and the location. And as you can see, the location changes to create a new folder, mkdir, and the folder name. So let's say I'll create a folder called example. And so it is created. Now again, we have to move to the mkdir. So again, CD and the folder name which we have created. So we are in the folder right now. So we'll check with Python. So it will be Python -m and environment. So it will be Python/m and the environment which is venv. So as you can see, there are no errors, so you can move forward. Next, to get into the environment, we have venv/scripts and /activate. So for the environment, we have venv scripts and activate. So it is activate and enter. So we'll know when it is activated when you see venv here before even the command starts. So now we are into the Python and the environment completely. Next, we'll move on to creating a .py folder so that it can store our code. So for that, we have touch, let's say the folder name as QA and .py. And it has created the RAG QA file for us to enter the Python code. So in that, we need to initially install all the libraries. So you can go for pip, install, let's say the basics are datasets. Let's do that. It will take a little bit of time depending on your system's processor. So since I've already installed, next you need to install the transformers, which I won't run it. So the code for that is pip install transformers, FAIS, CP torch, dataset sentence transformers. So you can install this as well. And apart from this, you can also install sentence piece, which is also a major part of the installation process. Now, after installing, let's get into the .py folder. So it will be Python and the folder name what we have given. So what was the folder name? ragqa.py. So let's type in ragqa.py. And as you can see, we have already into the .py folder. Now let's go back to the folder that we have created. So you can see the folder is already here and we have the environment and we have ragqa.py. Now if I click on that, Visual Studio Code or any Python editor should open. So here the code will be generated here. Now here I've already added the code here. We'll go line by line what it does. So firstly, we are again importing the necessary libraries, which is transformers, sentence transformers, FAIS, and also NumPy. T5 is a text-to-text model, which means it treats every task, question answering, summarization as a text generation problem. And coming to tokenization, this will convert text into numbers so the model can understand it. Next, we have sentence transformer. This import is for the retriever part. Sentence transformers convert sentence into embeddings, numerical representation that capture meaning. This is what allows us to compare queries and documents cinematically. Next, we are importing FAIS and NumPy. FAIS is used for fast similarity search, and NumPy, as usual, we all know that it works with numerical arrays. Together, they allow efficient retrieval of relevant documents. Next, we move on to loading of the documents. So as you can see, we have loaded the documents of sentence model is equal to sentence transformer all mini LM L6 V2. So this is a pre-trained sentence transformer model. This model converts text into embeddings of fixed size. Here I'm not training anything here. I'm using a ready-made model which is common in RAG world RAG systems. Next we have documents. So as you can see, I've loaded the documents and these are the document names. These documents act like a knowledge base. In real application, this could be any kind of PDFs, web pages, company documentation, or even any kind of databases. For demonstration, here I'm just using a simple text format. Next, if you come here, we have to encode the document. So for that, here you can see we have document embeddings is equal to sentence model dot encode. We are passing the documents and convert to tensor is equal to true. This line converts each document into embeddings. Each embeddings is a numerical vector that represents the meaning of the document. Now this convert to tensor is equal to true ensures the output is compatible with deep learning models. Now let's move on to creating the FAISS index. So firstly, we have dimension is equal to document embeddings.shape. This line gets the dimension of the embeddings. FAISS needs to know this to create the index part. And next we have index is equal to FAIS.index flat L2 dimension. This creates a FAIS index using L2 distance. Now L2 distance measures how close two embeddings are. Small distance means higher similarity. Then we have index.add np.array document embeddings. Here I have added all the document embeddings into FAIS index. Now the retriever is ready to search. Coming down next we have retriever function, which is load a pre-trained TF model and tokenization for the next generation. So again I am defining a function which is retrieve documents and passing query and top K1. This function retrieves the most relevant documents for a user query. And then inside that we have query embeddings is equal to sentence model dot encode, and we are passing query to convert to tensor again is equal to true. Here we convert the query into an embeddings using the same model. This ensures consistency between query and the document embeddings. Next we have indices is equal to index.search, np.array query embeddings and top K. Now this is FAISS search the index and returns the most similar documents, indices, top K control, how many documents we retrieve. And next we have retrieve docs is equal to docs.I for I in indices 0. So using the indices, we fetch the actual text documents and then we are returning the document which was searched. Next we have another function which is RAGQA and we pass query to it. This function will combine retrieval and generation. Firstly, we have retrieve docs is equal to retrieve docs and we are passing in query. First, we have to retrieve the relevant document, so that is performed here. And next, we have context is equal to join retrieve docs. We combine retrieve documents into a single context string. Next, we have input text is equal to F question query and the context. Here, we have created the input prompt for the model itself. This is where augmentation happens. The query is enriched with context. Next, we have input IDS, which is equal to tokenizer, input text, return tensor pt dot input IDS. The tokenizer converts text into model readable format. Next, we are generating an answer using the T5 model. So you can see here generate IDS is equal to model generate input IDS, the length and beams early stopping, which is equal to true. Now here the model generates an answer. Beam search improves quality by exploring multiple candidate outputs. And then lastly, we have output is equal to tokenizer.decode, and we are generating ID as 0, skip special tokens, true, and return the output. Here the generated output is converted back into a readable text. After this, we come to the running part where we are passing query is equal to what is the capital of France. So if you go to the documents or the datasets that we have given here, the first sentence is Paris is capital of France, known for its art, fashion, and landmarks. And we have Eiffel Tower is one of the most famous landmarks in Paris, France. And we have a museum in Paris, which is the world's largest art museum and a historical moment. So here we are asking the question is what is the capital of France? What should be the answer? The first sentence, right? Paris is the capital of France. Out of all these data sets, we should compare the question or come up with the answer, which is the first sentence. So just save this. And also after giving the query, we have to pass the answer also. So answer is equal to rag QA. We are calling the function. We are giving it the query and printing the answer. So for running, again come back to the command prompt and Python and the file name .py. So let's see the output. So as you can see, it will run the code and each and every step is there. And here you can see answer is Paris from the datasets that we have provided. So this is a simple RAG system which was created using command prompt. So we will move on to Jupyter Notebook. Firstly, we need to make sure that Jupyter is already installed. So for that, you can run this code, which is pip install Jupyter. And if you press enter, it will get installed. You have a desktop version which you can go search it and download it. Since I've already installed, I'll just open it. So for opening, we have to type in Jupyter Notebook and it will lead us to a different window. So as you can see, this is the Jupyter Notebook. And here you will see all the files which is there in the system. And any coding, any changes that you're doing here, it will be reflected in the command prompt. So let's go here, go back to file. These are the things. So for a new creation of a project, you can just add a new folder and then name it, open it, and then create a notebook from there. So for Python, we have Python 3. So create and it will lead to a Jupyter Notebook. And this is the interface of Python. And here you can create or write your code. Now in the first program, I showed a RAG-based question answering system. Now in the second program, I'll be demonstrating summarization using RAG. The motivation here is very practical. In real life, we often deal with large documents, articles, reports, or even research papers. Reading everything manually is a time-consuming process. So instead of summarizing everything blindly, RAG allows us to retrieve only relevant documents and then summarize them accurately. So here I'll be using Jupyter Notebook for the demo. Jupyter is useful because it allows step-by-step execution, which will go through each sentence code. Outputs are visible immediately, and it's easier to explain the logic in an interactive way. This makes it ideal for experimentation or even demonstrations. Now here I have again a code for a simple program for summarization. Firstly, we are starting with installing transformers as we did in the previous program. So I told you about the step-by-step running, so you can just run this. Next, again, we are also installing sentence piece. And as you can see, already satisfied because I've already run this. And then you can go ahead and run the sentence piece as well. Now this is an optional step of installing GitHub, which is not really required. Let's go into the main programming part. Again, firstly, start by importing the T5 model. And T5 treats every task as text to text as we have seen earlier. And it's important for summarization because a simple generation task will take about few seconds instead of taking hours. Next, we have sentence transformer, import sentence transformer. This is important for retrieval component. Sentence transformer convert text into embeddings that capture cinematic meaning also. Next, we are importing FAIS and NumPy. It's the same one. Next, we'll move on to loading a pre-trained sentence transformer. So here we have sentence model is equal to sentence transformer. We're using the same model. And then again, we are loading the documents. What are the documents here? Eiffel Tower is located in Paris. France is the most. So let's adjust this is the most. I've given some more sentence as well. And next we move on to the encoder part. So you can see document embeddings is equal to sentence model dot encode. This encodes the entire document into the embeddings. And then same procedure, we are creating a FAIS index and then loading a pre-trained DeFi model and tokenizer for the test generation as well. Here also we have two of the functions. One is for retrieve documents and summarization. So again, retrieve documents is similar to the previous one. Coming to summarization here, this function will combine the retrieval and summarization. So firstly, we have retrieve docs is equal to retrieve documents query. This is first relevant documents that are retrieved. This ensures we are summarizing only relevant information. Next, we have context is equal to space.join retrieve documents. Here, retrieved documents are combined into a single context. And then we have input text is equal to f.summarize context. This prompt tells us the model explicitly to summarize the content. Then we have prompt design is very important in generation task. So we have next input IDS is equal to tokenization, input text, return tensor is equal to PT. So here the tokenizer converts the input into tokens. The model understands. Again, next we have generator IDS. Similarly, we have assigned the length, beams, and early stopping is equal to true. This model generates a summary. Beam search improves quality by exporting multiple possibilities. And lastly, output is equal to tokenizer dot decode, and we are passing generated IDs. Skip special tokens is equal to true. Here, the generated summary is decoded into readable text and also returned. Now here, again, we are assigning query is equal to tell me about famous landmarks in Paris. The summary is again given the query. So we are passing summary to here and then printing the summary. So what should be the answer? The question is tell me about famous landmark in Paris. So if you search the entire document, famous landmark, the Museum of Paris is the largest art museum. It was originally, and if you search, there is no landmark here. So we'll see what is the answer for this. So let's just run this cell. It will take some time. So there are few errors regarding the array and all, which we can fix with the GitHub. And here you can see summary. The Eiffel Tower is located in Paris. France is one of the most recognized structures in the world. It was constructed so and so. So it has taken a concise answer from a huge data set. You can fix this by just copy and pasting in any AI tool and it will give you how to fix these errors. I think I have not run the GitHub one. So those are the issues caused due to this. This program demonstrates how RAG can be used for summarization. The architecture remains the same as question answering. Only the task changes. This shows the flexibility of RAG in solving real-world problems. Now next we'll be creating a dialogue system. In the first program, we saw question and answering, one question and one answer. In the second program, we saw summarization, which retrieves content from the main dataset and summarize it. Now the third program is different. This is a dialogue system. A dialogue system is not about a single interaction. It is about continuous conversation. For example, a user may ask question, what is RAG? And then ask, why is it useful? Then followed up with multiple other questions. All these questions are connected. So the challenge here is not just answering, the challenge is staying consistent across multiple turns. This is where RAG is very important. So I've already created, let me just open it. Firstly, we are giving the knowledge base, which is the documents. I've given a RAG stands for Retrieval-Augmented Generation as a sentence and other things related to RAG. I've given a small data set, increase the data set as per the knowledge base is. The more the knowledge base, the better the conversation, more precise the answers, and more wider amount of questions you can ask. So next, the main program will start by importing string. This is important because it cleans user output. Users naturally type punctuation like question marks. So if we don't know how to handle these, So for that, we need to figure it out using import string. Then I have a function named retrieve and I'm passing query and documents. This function retriever, its job to decide which documents are relevant for which query. And here we have cleaned query is equal to query.lower translate str mark trans, and then we are punctuations and all etc. we have mentioned. Here I have converted the query to lowercase and remove the punctuation. This makes matching more reliable. Then we have query words is equal to cleaned query dot split and results. The clean query is split into individual words and the result with an empty array which will store documents that match the query. And here we have a for loop for doc in documents, for word in query words, if word in doc, lower result append dot break. Now we loop through every document in the knowledge base. For each document, we check every word in the user query. If any query word appears in the document, we treat that document as relevant and then result it and break the loop. And again, we are returning the result. Now moving on to the next function, which is generate response, we have passing query, retrieve docs and chat history. So this function is generator. It takes the user query, retrieve documents, conversational history, etc. If not retrieve docs is also there, there will be returning of I couldn't find relevant information. This handles the case where retrieval fails. It avoids hallucinations and answer. Next we have response is equal to based on what I found. This clearly tells the user what the answer is based on retrieved data. Then we have for doc and retrieve docs. We now loop through the retrieved documents and then we have response plus is equal to documents. Each document is then added to the response. This makes the system transparent and explainable. And then we are returning the response. Now what about the chat history? Firstly, allot chat history with an empty list. In advanced dialog system, chat history helps maintain context. Here we keep it simple to show the structure. Next we have user query in the while loop, which is input user. If user query is equal to exit, which is if I type in exit, this allows the user to exit the conversation. And then we have chat history dot append, which is passed again by a user query. Each user query is stored in history. Then we have retrieve docs is equal to retrieve user query documents. For every turn, retrieval happens again. This is very important in dialog RAG. Again, followed by we have response is equal to generate response, user query, retrieve documents, chat history. The response is then generated and displayed. Now let's just run this entire cell. And after running, you'll have a dialog RAG system, type exit to stop. Now you can ask questions based on your databases. Let's say what is RAG? So it's not defined. Okay, I've not run all the cells, so let's run it one by one. So here, what is RAG? And here you can see assistant based on what I found. RAG stands for Retrieval-Augmented Generation. RAG improves accuracy by retrieving relevant documents before getting an answer. So this was fetched from the databases that we have given. Now that you have seen the demo working end to end, let me quickly show you how this RAG system is organized at a project level. The folder structure is very important because in real-world AI systems, clean organization is what makes projects scalable, debuggable, and also production-ready. The first folder will be your root folder, which is RAG project here. Everything related to this is RAG application lives inside this directory. Next, under that, we have RAG env, which is our virtual environment. This isolates all Python dependencies so the project runs consistently across systems. In real projects, this avoids version conflicts and dependency issues. Next, we have the data folder, which is split into two parts. The raw folder stores the original input documents, which includes PDF, text files, or even documents that we want the RAG system to search. These files are never modified directly. They act as a source of truth. The processed folder, which is data/processed, contains the FAIS index. This is where the vector embeddings are stored after processing. So once the documents are chunked and converted into embeddings, they are saved here for the fast semantic search. The core logic of RAG system lives inside the app folder, which is ingest.py. You can name it as accordingly. It is responsible for loading documents, creating embeddings, and building the FAISS index. This script is usually run once or whenever the new data is added. RAG pipeline.py handles the entire RAG workflow, retrieving relevant documents and generating responses using the language model. This is the heart of system where retrieval and generations come together. Finally, we have UI.py, which provides a simple user interface that allows users to ask questions and interact with the RAG systems. The .env file stores sensitive information like the API keys and configuration values. This keeps secrets out of the code and makes the system more secure. The .gitignore file ensures that unnecessary or sensitive files like virtual environments and indexes are not pushed to version controls. And the requirements.txt lists all the Python dependencies needed to run this project. This makes it easy to reproduce the system on any machine. So this project structure reflects how real production of RAG systems are built, with a clear separation between the data, processing, retrieval logic, and user interaction. So through these projects, I wanted to show you that RAG is not just a theoretical concept. It can be implemented practically to build reliable real-world AI systems that combines external knowledge with intelligent language generation. If you found this video informative, do like, share, and subscribe to Simplilearn. Thank you and keep learning with Simplilearn.